Hey guys, tonight we're heading to the most temperamental planet in the neighborhood, Venus. The sky is thick, the ground is toasty enough to bake bricks, and the clouds. Ew, the clouds. Imagine floating through yellow fog that stretches endlessly in every direction, swirling gently like layers of custard whipped in slow motion. The sunlight doesn't exactly shine here. It diffuses, bends. It gives up halfway through and just lingers, casting everything in a hazy, buttery glow that feels less like day and more like a very committed golden hour. You float just above the cloud tops now, watching the sulfur-stained sky churn beneath you. The atmosphere rises in tiers like an atmospheric tiramisu, each layer thicker, hotter, and moodier than the one above. There are no clear skies, no cheerful blue. Just cloud upon cloud stretching across the entire planet like a quilt made by someone who ran out of pastel and decided to go full storm cloud instead. You probably won't believe this, but beneath this soft blanket of vaporized doom is a planet spinning the wrong way. Like literally. Venus is doing a slow, sulky pirouette in the opposite direction of most other planets. And we'll get there in a second, I promise. But first, so before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're in the mood, drop a comment with your location and local time. I love seeing where and when you're all tuning in from. Now dim, the lights maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. As you hover over Venus, you feel the pressure even way up here. This is a planet with opinions, bold ones. The clouds made of sulfuric acid droplets aren't just thick, they're actively reflecting about 75% of the sunlight that tries to enter. It's like Venus looked at the sun and said, "Thanks, but I'm good." From orbit, you can't see the surface at all. Not a glimpse. Radar is the only thing that's ever been able to peek below bouncing signals off the dense atmosphere to sketch out ghostly outlines of mountains, valleys, and the occasional, oddly circular volcanic dome. But you'll hear more about those later. For now, let the clouds drift past your view like slow-motion fog on a window pane. This is the brightest object in the night sky after the moon, and yet it's a planet wrapped in mystery. It doesn't want to be understood. It wants to be watched from a distance, admired, and then left alone to spin at its own rebellious pace. And about that spin, while Earth is busy twirling around once every 24 hours, like it's got somewhere to be, Venus takes its time. A single rotation takes 243 Earth days. That's right. One day on Venus is longer than its year. But even better, that long, lazy day is spent rotating in the opposite direction from almost every other planet. Venus isn't just slow, it's contrarian. If Venus were in a group project, it would be the one who shows up late, rewrites everything in cursive, and then leaves early, and somehow still gets the same grade. It's no wonder the ancient cultures associated Venus with love and beauty. It's magnetic dazzling and completely impossible to get close to without everything going spectacularly wrong. But as you float along, letting the gentle churn of the clouds lull your senses, you realize Venus doesn't care about making sense. It doesn't explain itself. It just is. There's a kind of power in that, a softness that hides a fierce, unyielding truth. Below you, layers of sulfuric acid clouds catch the faint light of the sun, scattering it in all directions. The winds here far above the sluggish spin of the planet are moving fast. Like finish a lap around the planet in 4 Earth days fast. They race along the cloud tops, creating a strange paradox. A planet that barely turns with an atmosphere that refuses to stand still. Scientists still argue whether this atmospheric superrotation is connected to the slow backward spin. Is it cause effect? Cosmic coincidence? Nobody knows. The data is incomplete. The models are fuzzy, but the winds keep racing and the planet keeps turning the wrong way. And so you drift, wrapped in this soft, acidic embrace. There are no landmarks to follow, no mountain peaks poking through the clouds, just a vast, featureless sea of yellowish mist. It's almost peaceful if you ignore the temperature's pressures and sulfur, but we'll let those details stay politely in the background for now. Let the pace slow. Let the brightness dim. Let Venus welcome you not with answers, but with warmth. Lots and lots of warmth. You're still hovering there, just above the haze when it hits you. Venus isn't just turning slowly, it's turning the wrong way. Most planets, including our Earth, spin counterclockwise when viewed from above the sun's north pole. It's standard cosmic choreography. But Venus pirouettes in reverse. A slow, deliberate clockwise twirl, as if it woke up one day, looked at the rest of the solar system, and thought, nope, not for me. This motion is called retrograde rotation, and Venus does it with the flair of someone confidently walking into a room full of people moving the other direction. There's no apology, no hesitation, just reverse elegance. Now there are only two major planets in the solar system that do this little backward dance, Venus and Uranus. But while Uranus just decided to lie down and roll sideways like a dramatic lounge chair, Venus keeps things subtler. From space, it looks totally normal until you realize that the sun would rise in the west and set in the east if you could ever see the sun from the surface, which you probably can't, thanks to the clouds that act like the universe's most committed blackout curtains. This backwardness isn't just quirky, it's baffling. Venus's retrograde spin is one of those things that sounds like a glitch in a space simulator. Scientists still argue whether the spin is the result of a slow internal shift over billions of years, or the leftover scar of a massive collision early in Venus's formation, maybe with a rogue planet or an especially moody asteroid. One theory suggests that Venus might have once spun the normal way, but tidal forces from the sun gradually slowed it down, stopped it, and then reversed its spin like hitting rewind on a record player, which sounds cool until you realize this cosmic rewinding process would take hundreds of millions of years and involve a delicate balance of gravity, inertia, and solar nagging. It's like trying to make a planet do a U-turn using only polite persuasion and extreme peer pressure. And yet it worked. Somehow, Venus now spins backwards so slowly that a full day, one complete spin on its axis, takes longer than its entire year, one orbit around the sun. You think your Mondays feel long. Venus is the queen of extended work weeks. If you lived there, and let's face it, you wouldn't last 5 minutes, you'd have to wait 243 Earth days just to call it tomorrow. Here's a fun side note. Because of how Venus spins and orbits, if you stood in just the right spot and survived long enough, you could actually watch the sun rise in the west, pause reverse direction, and set in the west again. It's solar whiplash. Astronomical gaslighting. The sky is just messing with you at that point. But back to that stubborn spin. Venus doesn't care that it's the odd one out. It just keeps turning in its slow motion reverse like a planet performing a cosmic moonwalk. Every second of that motion is a quiet rebellion, a gentle reminder that not everything in the universe follows the same rules. You watch the clouds spin in one direction, while the planet underneath crawls along in the opposite. It's like watching a conveyor belt on top of a lazy Susan. The effect is mesmerizing slow beneath, fast above, all wrapped in sulfur and sunlight. And for all the confusion Venus causes, it doesn't seem to be in a rush to explain itself. There's no guidebook, no helpful plaque in orbit, just a dense reflective atmosphere and a refusal to participate in the standard planetary spin class. Venus is sometimes called Earth's sister planet. They're nearly the same size, roughly the same mass, made of similar materials, but it's like one sibling went to yoga class and drinks herbal tea, while the other joined a heavy metal band and refuses to wear shoes. The more you learn about Venus, the less it makes sense, and the more it charms you. It's not chaotic in the way Jupiter's constant storms are, or mysterious like Neptune's vanishing spots. Venus is enigmatic because of how calm it seems, how quietly it defies expectations. You drift slowly around the planet now, letting the clouds sweep past beneath you in their super rotating glory. Venus itself spins at a crawl, but the upper atmosphere laps the planet every 4 Earth days. That means if you were somehow floating up here in a very heat-resistant hot air balloon, you could circumnavigate Venus in less than a week, while the ground below you hasn't even shrugged. This difference between the planet's spin and the atmosphere's speed is one of Venus's most bizarre mysteries. Scientists still argue whether it's driven by solar heating planetary waves or the sheer determination of sulfuric acid to win a race against gravity. Some models suggest that energy trapped in the thick clouds gets funneled into massive wave systems, which then help push the atmosphere around in these wild 4-day sprints. There's even debate about whether Venus's slow backward rotation helps create this phenomenon, or is simply another effect of the same bizarre internal balancing act. But none of that matters right now. Not up here, floating calmly above the stormy swirl. You don't need to solve Venus. You just need to watch it. Feel the slow pull of its gravity. Let your thoughts drift like the winds that circle it. Venus isn't in a hurry, neither are you. You settle deeper into orbit, now caught between the golden hush of sunlight and the creamy swirl of cloud cover below. Venus doesn't rush you. It never does. That's part of its charm. Everything here moves with the sleepy elegance of a daydream, including the passage of time itself. Let's talk calendars for a moment. Not the kind with kittens and holidays, but the kind that reminds you how weird Venus really is. Because Venus takes 243 Earth days to rotate once on its axis, and only 225 Earth days to orbit the Sun. You end up with this peculiar situation. A day on Venus is longer than a year. Not figuratively, literally. You could celebrate a birthday before lunch ever arrives. Imagine standing on the surface, just hypothetically. Because standing on the surface would mean being crushed and cooked simultaneously. And we're aiming for sleep, not nightmares. But imagine it anyway. You arrive, set your clock, start your day. The planet begins to turn ever so slowly beneath you. Months pass. The sun begins to rise. You blow out your birthday candles. Then at some point later, well after the cake has dried out and the existential dread has settled in, the sun finally sets back where it came from. And just to make it more confusing, because Venus also rotates backwards, the sun would appear to rise in the west and set in the east. You wouldn't just be waiting forever. You'd be waiting in the wrong direction. All of this makes for one of the most beautifully confusing timekeeping challenges in the solar system. Scientists had to invent a concept called the solar day, the time it takes for the sun to return to the same position in the sky, factoring in both the planet's rotation and orbit. On Venus, that number lands at about 117 Earth days. So if you were trying to build a sundial here, good luck. You'd need one that reads in thirds of years and flips backward. Still, there's something cozy in that. Venus doesn't care about your calendars or your clocks. It has its own rhythm, like jazz, or one of those metronomes that slowly walks off the piano because the table isn't level. And somehow, that's the tempo it wants to keep. You might wonder, though, how did it get this way? How does a planet end up spinning so slowly and in reverse? Did it always spin this way? Or did something dramatic happen in the early solar system? Scientists still argue whether Venus was once a fast-spinning, forward-facing world that gradually slowed down due to tidal forces from the sun, sort of like a cosmic brake pedal, pressed very, very gently for billions of years. Another camp thinks a massive impact might have flipped Venus completely, making it rotate backwards relative to its orbit. And some propose a third option, that the thick atmosphere and tidal forces work together over eons, not just to slow Venus down, but to flip it inside out and backward like a sock coming off your foot in slow motion. Fringe researchers have even floated the idea that Venus may have once been tidally locked, always showing one face to the sun, before some resonance nudged it into this current lazy spin. The thing is, Venus is so covered in mystery soup, with so few surface markers and no visible magnetic field to study spin history, that it's nearly impossible to be sure. You can feel the uncertainty now hovering above a planet that hides more than it reveals. There's no aha moment here, no final twist in the story. Just a slow roll of possibility like a fog drifting through theories that never quite settle. Back on Earth, we crave neatness, clear timelines, predictable systems. But Venus reminds you that not all beauty comes in tidy packages. Sometimes it comes wrapped in sulfur, shrouded in acid clouds, rotating backwards with a shrug and a smile. Still, despite the confusion, Venus's bizarre timing doesn't seem to have thrown off the rest of the solar system. The other planets just let it spin how it wants, like a neighbor who mows their lawn at 3 a.m. Odd, but harmless. And if you zoom out far enough, the mismatch becomes part of the harmony, like an offbeat drum keeping time in a sleepy cosmic waltz. Here's something surprisingly sweet. Because of its orbit, Venus gets closer to Earth than any other planet. Not Mars, not Mercury. Venus. It's our nearest neighbor in space, just very antisocial about it. Every 584 Earth days or so, Venus comes close enough to make astronomers sigh with hope, then remind themselves that it's still hotter than a pizza oven filled with science homework. So as you drift just above its hazy edge, time slows down with you. There's no ticking here, no urgent pulses, just a planet spinning lazily the wrong way around, wearing clouds like a robe and ignoring the clocks. Let it turn. Let it take its time. The clouds beneath you remain as thick and unbothered as ever, swirling like a pot of ivory soup left on the stove too long. There's something oddly hypnotic about them, the way they curl and twist with no clear start or end. They never hurry. They never clear. Venus has been wearing the same stormy blanket for centuries, and it shows no signs of taking it off. And what's under that blanket? That's where the real mood begins. You sink, just a little figuratively, speaking into the upper layers of Venus's atmosphere. Here, the clouds are made primarily of sulfuric acid. That's right, acid. The same stuff that would melt your raincoat and ruin your day on contact. It's not a place for picnics or stargazing, but from up here, with no physical body, to melt or goggles, to fog, it's kind of beautiful. The light scatters through the clouds in a way that softens everything. Shadows fade into one another. The sun becomes a gentle golden smear in the sky. You float like a thought drifting through a toxic dreamscape of yellows and grays. Here's a mainstream fact for you. Venus's atmosphere is about 96% carbon dioxide, with clouds of sulfuric acid and trace amounts of other gases. The pressure down on the surface is about 92 times what you're used to on Earth. That's like being 3,000 feet underwater. You'd be crushed before you could say, I thought this was a good idea. And the temperature. Oh, only about 465 degrees hotter than Mercury, even though Venus is farther from the Sun. That thick CO2 blanket traps heat with the efficiency of a greenhouse designed by a control freak. It's the ultimate runaway greenhouse effect, the poster child for planetary overcooking. But here's the fringe tidbit. Despite all that hellish pressure and heat, there's a Goldilocks zone floating around 50 to 60 kilometers above the surface, where the temperature and pressure are actually quite Earth-like. Not too hot, not too cold, not too pressurized. Just right, if you ignore the acid. That's led some researchers to imagine airships or floating observatories in this region. Big balloon-like spacecraft drifting gently on Venus's winds, studying the atmosphere from the one layer where conditions wouldn't immediately squish or scorch their instruments. Kind of like a cruise for robots. A very cautious, very corrosion-resistant cruise. Scientists still argue whether this middle atmosphere zone could be a place to explore long-term. It's inhospitable, yes, but not impossible. Some even whisper about microbial life, high in the clouds, feeding off sulfur compounds and dodging acid droplets like microbial trapeze artists. You hover now in that hypothetical zone between crushing heat below and freezing space above. Around you, the clouds churn quietly. There's no lightning here, no thunder, just a soft hum of atmospheric motion. Venus's winds at this altitude zip along at over 200 miles per hour, dragging the entire cloud system around the planet in just 4 Earth days. That's faster than the planet itself rotates. The clouds lap the surface like race cars circling a lazy tortoise. And yet, despite that speed, everything feels calm. Because there's no ground, nothing crashes. There are no hills to break the wind, no trees to rattle. It's just endless air, endless acid, and endless elegance. Even chaos gets smoothed out on Venus. You start to notice the patterns, the way the clouds spiral near the poles, the subtle shifts in color, from ivory to amber to pale brown. Sometimes high-altitude waves ripple through the clouds, faint but visible, like someone dropped a pebble into a giant cup of tea. Scientists have spotted bow-shaped features in Venus's atmosphere that stretch thousands of kilometers. They think these might be planetary-scale gravity waves triggered by air flowing over features on the surface mountains hidden beneath the clouds, silently shaping the weather above them. Scientists still argue whether those waves affect the entire atmospheric circulation or are just localized ripples that come and go. But either way, they're another reminder that Venus, while mysterious, is not still. It's always moving, always spinning, always simmering. Here's something oddly romantic. Venus has phases just like the moon. From Earth, you can watch it grow from a crescent to full and back again as it orbits the sun. Ancient astronomers called it the morning star or the evening star, depending on when it appeared in the sky. For centuries, people thought it was two separate stars. That's how shiny and dramatic Venus can be. You think about that now, how something so bright, so seemingly pure in our night sky can be so intense up close. Venus is like a celebrity whose Instagram feed is all sunshine and glow, but whose backstage reality involves a lot more fire and acid. Still, you can't help but be impressed. Venus doesn't hide who it is. It simply is bright backward and boiling, a planet that knows how to make an entrance and leaves the explanations to everyone else. Above the cloud tops now, the sky is starting to darken. You're rising slowly back into thinner air. The glow fades. The acid mist gives way to space. The planet rolls on beneath you, slow and silent, still turning the wrong way, as if it has all the time in the world. And it kind of does. You look down one last time at that swirling mass of clouds and carbon dioxide. It's deadly. It's magnificent. It's Venus. And it doesn't care what direction anyone else is spinning. Venus shrinks slightly beneath you as you glide higher, and with the haze of its upper clouds thinning behind a new detail, comes into focus the strange symmetry of its shape. The planet is round, yes, but not in the show-offy way of Saturn, with its dramatic rings or the moody blotches of Mars. Venus is almost eerily perfect, smooth, featureless from above, like a billiard ball that someone left in the oven for too long. But of course, perfection hides secrets. And Venus hides plenty. Let's descend again, figuratively. Not too far, just enough to consider what's beneath those clouds we've been politely hovering over. Because while Venus might look like a sleepy swirl of cream from space, its surface is anything but calm. Here's your mainstream fact. Venus has more volcanoes than any other planet in the solar system. Over 600 identified so far, though some researchers think the real number might be closer to 1,000,000 if you count the small ones. That's right, 1,000,000 volcanoes. It's less a planet, more a poorly timed geology experiment. But here's the twist. None of them are visibly active, at least not when we're watching. And yet, they might be. Some scientists believe Venus is still volcanically alive, just very discreet about it. In 2023, a study of old radar data from NASA's Magellan mission revealed that one volcanic vent had changed shape over time, possibly indicating an eruption. It's like Venus coughed once and hoped no one would notice. Venus's surface is made mostly of basaltic rock, smoothed over in wide-sweeping plains by ancient lava flows. You've got massive highlands like Ishtar Terra and Aphrodite Terra rising through the clouds like sunken continents. There are coronae too. No, not the beer or the virus, the geologic kind. Huge ring-shaped structures that form when hot material from the mantle pushes upward, bulging the crust and creating a circular landscape that looks suspiciously like the planet's trying to pop a zit. Scientists still argue whether coronae are signs of ongoing mantle plumes, columns of heat rising from deep inside the planet, or just ancient geological scars. Either way, they suggest that Venus's interior is still simmering, quietly, like soup left on the lowest burner. Now, you'd think with all this volcanic potential, Venus would have a surface shaped by plate tectonics, like Earth. But no. Venus doesn't do plates. It's more of a one-piece crust, a solid shell that expands and contracts, maybe cracks, but doesn't really shift around in neat jigsaw pieces. It's the baking sheet model of geology, one giant cookie, no slices. One fringe theory suggests Venus used to have plate tectonics and lost them, that at some point the planet simply locked up. Another theory posits that Venus never developed plates at all due to its intense heat and high pressure. Without water to lubricate the crust, it might have lacked the flexibility needed to fracture and slide. And then there's the idea of catastrophic resurfacing. Sounds dramatic, right? That's because it is. Some researchers believe Venus might periodically wipe the slate clean, melting large portions of its surface in massive volcanic events that resurface the entire planet. No erosion, no mountain ranges worn down by time, just planetary reset. A few 100 million years pass, and then splat. Lava everywhere. This helps explain something odd. Venus's surface doesn't seem to be that old. Most of it is only a few 100 million years old, geologically speaking. Which is weird because there aren't small impact craters. Usually you see a mix old worn out craters and newer ones. But Venus's craters all look fresh, suggesting a single resurfacing event erased the older history. Like the planet hit delete and started over. Scientists still argue whether that was a one-time thing or if Venus regularly has these dramatic lava tantrums. Either way, you begin to understand why studying Venus is like interviewing a very private person. She's charming, she's mysterious, and she keeps deleting her emails. Another bizarre surface feature worth noting: pancake domes. Yes, really. These are large, flat circular lava flows that look like well pancakes, but not the fluffy kind. More like the kind that didn't rise, cooked on low heat for an hour, and then were forgotten on the griddle. They're likely formed by thick, viscous lava that oozed out slowly and just stayed. Venus's version of a lava yawn. You float above one now, imagining the slow, steady bubble of heat rising from below a blister in the stone skin of a world that's been bottling up its rage for a few billion years. Here's a fun quirk. Despite all the geological evidence, no human-made spacecraft has lasted more than a couple of hours on Venus's surface. The combination of heat pressure and corrosive atmosphere turns landers into soup cans in record time. The Soviet Venera missions set records in the 1970s and 80s. Venera 13 lasted 127 minutes before it succumbed to the heat. Imagine designing a robot that could only survive as long as a lunch break and still manage to send back pictures. So we don't have rovers trundling around like we do on Mars. We don't have surface samples or rock collections. We've got snapshots, a handful of radar scans, and a mountain of questions. Still, there's something kind of elegant about that. Venus refuses to be poked and prodded. It's the only planet that's both next door and almost completely unknown. And maybe it likes it that way. You drift back up now, letting the hot, chaotic crust fade from view beneath its ceiling of clouds. Up here, it's quiet again. Smooth. Impenetrable. But you know what's under there now. You've seen the bruises, the bubbles, the still warm scars. And you realize Venus may spin the wrong way, but it's definitely not standing still. The clouds resume their patient, swirling beneath you, slow and persistent, like they know you're watching and have decided to give you the quiet show today. But your attention turns not to the sky or the surface, but to the clock. Not Earth's clock, not your wristwatch, but Venus's own slow, confusing timekeeping. Because if you thought the planet's retrograde spin was strange, just wait until you try to schedule anything here. Let's start with a mainstream fact. To help ground your sense of time, a single day on Venus, one full rotation on its axis takes about 243 Earth days. That's right. It takes longer for Venus to spin once than it does for it to go around the Sun. But wait, there's more. Venus's year one orbit around the Sun is only about 225 Earth days. So technically, Venus's day is longer than its year. That's like taking longer to blink than to finish a lap around the neighborhood. It's one of those facts that seems wrong, even when it's right. And if you want to add a little more spice because of the retrograde rotation, the Sun would appear to rise in the west and set in the east. Very, very slowly. You could sit through an entire Earth month and still not see the Sun noticeably shift in the Venusian sky. It's less sunrise, more a faint golden shrug. Scientists still argue whether Venus has always rotated like this. One popular theory is that it used to spin in the same direction as Earth and most of the other planets, but was flipped or drastically slowed and reversed by a massive collision in its early history. Maybe it took a hit from a rogue protoplanet, a cosmic sucker punch that altered its momentum forever. Or maybe it's the cumulative effect of gravitational tugs from the Sun and other planets slowly winding Venus backwards over eons. One fringe theory even suggests that tidal forces from Venus's incredibly thick atmosphere helped break its rotation. That's right, the air might have slowed down the planet. Imagine spinning a bowling ball through syrup. Eventually, all that resistance adds up. Venus, with its dense carbon dioxide blanket, may have thickened its own atmosphere so much that it became a kind of planetary emergency brake. It's a weird twist of fate. A planet that slowed itself down with its own breath. Now let's think about the implications of a 243-day-long rotation. First of all, it means that one side of the planet is exposed to the Sun for a very, very long time. Weeks and weeks of daylight that gently bakes the surface. Then comes the same length of darkness. But thanks to that thick heat-trapping atmosphere, temperatures don't change much. It doesn't cool off during the night because the heat can't escape. Venus is the ultimate thermal blanket, too good at its job really. And while this ultra-slow spin might sound like a planetary nap, it creates strange side effects. For one, it messes with atmospheric circulation in a big way. While the planet rotates lazily below, the upper atmosphere is moving much, much faster superrotation, they call it. Clouds zip around the planet every 4 Earth days. So above the surface, the winds race while the ground barely turns. It's like having a ceiling fan on turbo speed in a room where the floor never moves. No one fully understands how this superrotation started or why it keeps going. Scientists still argue whether it's driven by solar heating, planetary wave patterns, or some strange combination of vertical turbulence and atmospheric tides. Whatever the cause it means, Venus has a kind of split personality, lethargic below, frantic above. And here's a quirky celestial tidbit because of the alignment between Venus's orbit and its rotation. If you were standing on the surface, the Sun would rise only twice per Venusian year. That's 2 sunrises every 584 Earth days. The days are long, but the years are short. Venus is a planet where the concept of weekend might mean next century. All of this makes keeping track of time on Venus a nightmare. If you ever tried to build a clock there, you'd have to choose whether to sync it to solar time, which is weird and backwards, or to sidereal time, how long it takes to rotate once relative to the stars. Either way, you're signing up for a lot of math and very few coffee breaks. Still, there's something almost poetic about a planet that refuses to rush. In a solar system where everything spins and zips and races to complete orbits, Venus has opted for the long game. No hurry, no panic, just a slow, steady roll in the opposite direction, like a cosmic introvert strolling backward through a crowded plaza. You drift above it now, imagining what it would be like to live under such a schedule. To have sunsets that take weeks, mornings that unfold like slow-motion operas, nights that last so long you might forget the sun even exists. Venus teaches patience not by choice but by nature, and as you float higher again, letting the idea of backward time settle in your thoughts, the sky begins to darken. You're no longer bathed in that sulphurous golden glow. Space creeps in around the edges. The stars return, and below the planet turns slow, quiet, and stubbornly the wrong way. You smile a little, thinking, if there's any planet that could teach Earth to slow down, to take a breath, to maybe let the sun set a little more gently, it would be Venus. Even if she spins the wrong way, she clearly doesn't care. And maybe that's the point. You linger now just beyond the upper clouds, drifting slowly in the dull amber twilight. The light here is syrupy, soft and golden, not warm exactly, but thick like honey drizzled through a fog. The sun is still technically out, but you wouldn't call it bright. On Venus, even light seems to get tired, and as the planet continues its slow, sulky spin below you, it's time to address something both obvious and deeply weird: Venus's utter lack of a magnetic field. Now you may not think about magnetic fields very often, unless you're planning to navigate the wilderness with a compass, or you've got a fridge that collects motivational magnets like Pokemon cards. But planets think about them a lot, or rather, they have them for important reasons. They help protect atmospheres. They guide particles. They hold off solar wind and Earth. We've got a pretty decent one. It's generated by the motion of molten iron in our outer core, like a dynamo. A planetary battery humming quietly as it spins. Mars had one once, long ago, but it fizzled out, and without it, Mars lost much of its atmosphere to space. Poof. Gone with the solar wind. So, what about Venus? Well, that's where it gets weird. Here's your mainstream fact. Venus has no intrinsic magnetic field. None. Nada. Zip. It's one of the few rocky planets in the solar system without one. And scientists still argue whether that's because Venus's core isn't moving, isn't molten, or just isn't trying hard enough. Some think Venus's internal engine stalled. Maybe its slow rotation rate isn't enough to stir the molten core into motion, leaving the planet with no magnetic dynamo at all. Others argue the core might be too evenly layered. No convection, no spin, no field. Still others point to the possibility that Venus does have some internal motion, but it's not configured correctly to generate a global field, like a flashlight with the batteries in backward. But despite lacking a magnetic field, Venus still interacts with the solar wind in strange ways. It has what's called an induced magnetosphere, a weak temporary magnetic zone created by the sun's magnetic field pressing against Venus's upper atmosphere. Picture it like a ghost of a magnetosphere. It's there, but only when the solar wind feels like it. Not exactly dependable. Now, here's a quirky bit. Because of this setup, Venus actually grows a kind of magnetic tail behind it as solar particles stream past. It's called a magnetotail, and it stretches out behind the planet for millions of kilometers. Think of it like Venus leaving behind a wispy cosmic scarf every time it strolls past the sun. But back to the mystery. If Venus should have a magnetic field and it doesn't, what happened? One fringe theory suggests a catastrophic resurfacing event. The same lava flood we talked about earlier may have somehow disrupted or suppressed the internal mechanisms that generate magnetic activity, like pouring glue into a wind-up toy. Others suggest Venus simply cooled differently or locked its rotation too early in its evolution. It's like watching a car that could drive but never starts the engine. This lack of magnetism has consequences. Without a strong field to protect it, Venus's upper atmosphere is constantly being bombarded by solar radiation. Hydrogen and oxygen particles get stripped away by the solar wind drifting into space like tiny escaped bubbles. Over time, this contributes to atmospheric loss. Though Venus's atmosphere is so thick, it still hangs on better than poor Mars. Still, you can't help but wonder, would Venus be more Earth-like if it had a magnetic field? Could it have kept more water? Maybe developed milder weather? Maybe even harbored life? Scientists still argue whether a magnetic field alone could have made the difference, or if Venus's other quirks, its greenhouse effect, its slow spin, its volcanic enthusiasm, would have drowned out any chance of habitability anyway. And now, here's a quietly lovely twist. Despite all the magnetic weirdness, Venus still shows signs of electrical activity in its atmosphere. Some researchers think there may be lightning in the clouds, like on Earth, though it's hard to confirm. A few Soviet probes reported bursts of electromagnetic noise, but later missions were inconclusive. If lightning exists here, it would flicker inside clouds of sulfuric acid under a carbon dioxide sky. Not exactly comforting, but undeniably cinematic. Imagine that for a moment, a pale yellow flash in a sea of orange mist. Silent lightning across an acid storm. Venus doesn't need a magnetic field to be dramatic. She's already nailed the mood lighting. And while we're on moods, take a second to appreciate the emotional energy of this planet. Venus is the planetary equivalent of someone who shows up to brunch in full velvet, refuses to explain why they're late, and casually mentions they're no longer speaking to the magnetic field community. It just does what it does. You hang there now, orbiting above this quietly rebellious sphere, wondering how many other things we've missed, how many rules Venus is breaking without even telling us. A planet without a magnetic field, with a backward spin, with clouds made of acid and storms that don't thunder. And yet, it's beautiful, mysterious, still turning, still glowing faintly beneath the sunlight it barely reflects. Venus doesn't play by your rules, but it's still here. You glide farther along the edge of Venus, now letting the thick, hazy clouds drift past like lazy smoke across a theater stage. The light above remains soft and amber-tinted, and the silence is complete. No birds, no breeze, just the distant, muffled churn of a planet that doesn't care what you think of it. It's still spinning the wrong way, still wrapped in storms, still ignoring everything we thought we knew about how planets are supposed to behave. So let's take a moment to talk about visibility, or rather, the total lack of it. Here's your mainstream fact. Venus's surface is completely obscured by its clouds. No matter how good your telescope is, no matter how clear the night sky seems on Earth, you're never going to get a direct peek at Venus's surface without using radar. Its thick atmosphere reflects and refracts so much light that it's like trying to see the bottom of a bowl of milk through a pair of sunglasses. The clouds themselves are made of sulfuric acid droplets suspended in carbon dioxide, a kind of corrosive mist that stretches for dozens of kilometers above the surface. These clouds scatter sunlight in all directions, creating a constant diffuse glow. There are no sharp shadows, no patches of blue, just a blanket of gold and orange haze stretching from horizon to horizon. And the strangest part, Venus is the third brightest object in Earth's sky after the sun and the moon. Despite its shrouded surface, despite its clouded soul, it shines brilliantly in our sky. Ancient astronomers called it the morning star, and the evening star. The same planet, depending on when you look. But here's the catch. It's a trick, a beautifully bright disguise, because beneath all that shine is a planet you'll never see with your own eyes. Not really. Just radar echoes, just shadowy outlines, just thermal maps glowing faintly in the dark. And scientists still argue whether this invisibility is due solely to the thickness of the clouds or if there's more going on, complex light scattering unknown particulates, perhaps even photochemical reactions that give the upper haze its extra reflectivity. Venus's atmosphere is so dense, so layered, that light gets tangled in it, absorbed, bounced, blurred. Trying to observe the surface is like trying to read a book through a bowl of soup. Now for a quirky tidbit, when radar finally did map Venus, what we found was equal parts haunting and familiar. The surface is covered in plains, ridges, mountains, and giant volcanoes. There are impact craters fewer than you'd expect, suggesting the surface is geologically young, maybe 300 or 500 million years old. A blink in planetary terms. But what stands out most? The tesserae. These are vast highland regions of highly deformed terrain, cross-hatched and crumpled like continents that went through a taffy puller. Scientists believe they're some of the oldest parts of Venus's surface relics of a time before the lava flows came. They rise above the plains like the last pages of an ancient book. And here's where it gets both interesting and frustrating. We don't know what most of these features are made of. We can't study the rocks directly, and chemical analysis from orbit is limited. We've had a few landers, mostly from the Soviet Venera program in the 70s and 80s, but none lasted more than a couple hours on the surface before melting or being crushed. It's like trying to interview a dragon in a sauna with no translator and a 3-minute window. Still, those missions sent back photos. Grainy, faded images of rocky plains and a yellow sky. The pictures feel almost haunted, not because of what's in them, but because of how little they reveal. You see rocks, dust, maybe cracks in the surface, and then nothing. Radio silence. But oh, the theories that followed. Scientists still argue whether Venus has plate tectonics. On Earth, our crust is broken into plates that drift and collide, driving earthquakes and volcanoes. But Venus might be different. Its crust may be too hot and pliable to fracture into moving plates. Instead, it could be one big sluggish shell, occasionally convulsing in giant resurfacing events that melt everything and start over. One fringe theory suggests Venus's surface might undergo episodic overturns, huge events where the entire outer layer of the planet becomes unstable and sinks, allowing hotter material from below to bubble up and recoat the planet. Like flipping a pancake made of lava. And remember, those tesserae. Some researchers think they might be the only surviving witnesses to the pre-flip era. Ancient highlands that somehow escaped being buried by newer flows. If that's true, they might hold clues to what Venus was like billions of years ago, before the thick clouds, before the greenhouse inferno, before the surface became so utterly hidden. But for now, we can only guess. You drift now, just above the cloud tops where the light is a little clearer, and the views stretch a little farther. Below you, that golden sea of mist churns slowly, like a pot kept just below boiling. Somewhere under it, all the tesserae wait unseen, unmeasured, unresolved. Venus doesn't reveal her surface easily. She wears her clouds like armor, her haze like makeup. She hides her scars, her secrets, her history. But maybe that's okay. Maybe some planets don't want to be known right away. Maybe some are meant to be mysteries, not puzzles to solve, but stories to feel, to drift beside, to wonder about quietly without the need for answers. And as the glow softens around you and the clouds continue their slow dance below, you realize you don't need to see the surface. You already feel what's beneath. A world of hidden layers, lost heat, forgotten storms, unread pages, and maybe Venus likes it that way. You stay hovering above the golden swirl, now watching the clouds of Venus ripple and roll like taffy stirred by unseen spoons. The planet spins beneath you with the slow grace of something that has nowhere else to be, no schedules to keep. And honestly, same. It's time to talk about Venus's atmosphere again, but from a new angle. You already know it's thick. You already know it's hot. But now, let's look at it like a detective might, full of clues, layers of potential, whispers of what once was. Because see, buried inside that choking, toxic sky is a mystery that still keeps scientists up at night, perhaps literally depending on their grant deadlines. Here's your mainstream fact. Venus's atmosphere is made mostly of carbon dioxide, with thick clouds of sulfuric acid and just a trace of nitrogen. There's also water vapor barely and some other trace gases. But one of those traces, it got everyone's attention. In 2020, astronomers detected what they thought might be phosphine gas in Venus's upper atmosphere. Phosphine is a molecule made of one phosphorus atom and three hydrogen atoms. On Earth, it's associated with biological processes bacteria in oxygen-free environments can produce it. It's also found in industrial processes, swamps, and penguin poop. Yes, penguin poop. Let's not get distracted. Now, phosphine isn't easy to make. You either need very high heat and pressure or life, which means its presence on Venus sparked immediate speculation. Could something be living in the upper clouds? Cue the headlines, the interviews, the extremely cautious peer-reviewed papers, and of course, the rebuttals. Because here's the twist, the detection was fuzzy. The spectral signature used to identify phosphine was faint, and follow-up observations weren't entirely consistent. Scientists still argue whether it was really phosphine at all, or a false reading caused by sulfur dioxide, which is much more common and much less exciting. Or it could have been an artifact of the telescope, or a calibration issue, or a fluke. Still, the idea lingers. Because if there were life on Venus, it wouldn't live on the ground. It would float. High above the baking surface, in a narrow band of the atmosphere, where temperatures are more Earth-like, about 30 to 50 kilometers up. The pressure is similar to sea level here, and the temperatures are, believe it or not, almost comfortable. A balmy 30 to 60 degrees Celsius. Basically, hot summer day, uncomfortable, not incinerate your spacesuit uncomfortable. That zone is sometimes called the habitable cloud layer. Sounds nice, right? Like a floating spa resort. Except it's filled with sulfuric acid and high-speed winds. And your room service is a constant barrage of radiation and corrosive droplets. But maybe some kind of microbial life could exist there. Life that evolved to survive in acid. Life that floats in droplets or clings to particulates. Life that rides the winds and hides from the sun. Fringe. Yes. But not impossible. And even if it's not life, there's still a chemical party happening in those clouds. Complex photochemistry driven by sunlight particles from the sun and internal atmospheric dynamics, layers reacting with each other, molecules forming, breaking apart, rearranging. Venus's atmosphere is a giant chemistry set still bubbling after billions of years. Here's a quirky detail. Venus has an atmospheric superrotation. That's a fancy way of saying that while the planet spins painfully slow once every 243 Earth days, the winds in the upper atmosphere zip around the entire planet in just 4 Earth days. That's faster than the planet itself turns. It's like a race car lapping a parked car on the track, and nobody fully understands why. Scientists still argue whether this superrotation is driven primarily by solar heating surface-atmosphere interactions or waves within the atmosphere itself. Some think the whole system is self-sustaining momentum, transferring between layers, energy building up and never fully dissipating. Others think it's chaotic, a happy accident of physics, Venus being Venus again. What we do know is that this fast-moving upper atmosphere creates massive turbulence. Imagine air masses moving at hundreds of kilometers per hour, clashing and curling, pushing clouds into long spiraling waves. Some of these waves stretch for thousands of kilometers, visible even from Earth as faint streaks in ultraviolet photos. And every so often, these waves pile up and form something called a gravity wave. No, not those gravity waves that ripple space-time, but a type of atmospheric wave where air oscillates vertically due to gravity and pressure differences. These gravity waves can influence circulation weather and even affect the chemistry of the upper layers. It's like watching a planet breathe through invisible lungs. Now, here's a speculative delight. Some researchers wonder if these waves might interact with magnetic or electrical fields to produce temporary pulses of radiation, bursts of light radio noise, even something close to lightning. Venus has long been suspected of having atmospheric lightning, but the evidence is murky. Some spacecraft have detected Whistler's electromagnetic signatures of lightning, but the visual confirmation remains elusive, which means Venus might occasionally flicker with lightning inside its acid clouds, but we've never seen it clearly. Like a rumor told in whispers, never captured in a photograph. So, you float now right above that possible habitable zone. You can't see any microbes, of course. No blimps made of biofilm, no cloud jellyfish. Just sulfuric haze rolling endlessly, the color of bruised sunlight and old parchment. But you wonder, and Venus doesn't stop you. It just spins. Wrong. Way slow. Way dragging its clouds along for the ride. The winds howl quietly in the background. The atmosphere simmers with questions, and far above someone points a telescope at the sky and asks again, is something up there? Maybe, maybe not. But Venus doesn't need to answer. She knows how to keep a secret. The clouds stretch out beneath you like a golden sea, gently rolling, glinting here and there with the faint light of a distant sun. You hover above it all in a place that feels timeless, like a thought suspended in amber. Venus turns slowly below, pulling the air, the haze, and every question you've ever had about it into an endless whirl. It's time to go even higher now, out past the clouds, up towards space again. Because from this vantage point, you're going to see something that almost feels like a cosmic contradiction. Venus has a tail. Yes, a tail. Not like a comet's exactly. And not something you'd see with the naked eye. But it's there, stretching for millions of kilometers behind the planet, a long ribbon of particles, ionized bits of Venus's upper atmosphere torn away by the solar wind. and dragged across the void like the planet's own invisible scarf. Here's your mainstream fact. Venus doesn't have a magnetic field like Earth's. That's a big deal. Earth's magnetic field is what protects us from the solar wind, a constant stream of charged particles blowing out from the sun. But Venus, for reasons still debated, has no global magnetic shield. It's exposed, bare, and that changes everything. Without a magnetic field, Venus's upper atmosphere takes the brunt of the solar wind's impact. The result: some of the atmosphere gets stripped away, ionized, and carried off into space. Over time, this has formed what's called a plasma tail, a stream of charged particles extending away from the sun, following the planet's orbital path, like a trail of glitter on a black velvet runway. And here's the kicker: scientists still argue whether Venus ever had a magnetic field. One theory says it did long ago, when the core was more active, maybe spinning faster, generating a dynamo like Earth's. But over time, it slowed, cooled, and lost its magnetic mojo. Another theory says Venus never had a strong enough core differential to generate a proper dynamo in the first place. Either way, it's gone now, and that means the solar wind gets a front row seat to Venus's upper atmosphere. Now for a fringe tidbit, some researchers speculate that Venus's missing water, remember it likely had oceans once, is partly due to this very stripping process. Without a magnetic field, hydrogen atoms from water molecules in the upper atmosphere could have been knocked away by solar particles over billions of years. Oxygen atoms might have bonded with surface rocks or been lost more slowly. But the hydrogen poof, gone with the solar wind. And it's not just theory. Missions like ESA's Venus Express and NASA's Pioneer Venus Orbiter have gathered data showing charged hydrogen and oxygen ions escaping from Venus's atmosphere even now. It's slow, gradual, but constant. Like watching air leak from a balloon over centuries, you float farther out now above the edge of the atmosphere, where this invisible battle plays out. The sun blazes dimly from afar, its rays still powerful despite the distance. And here, in this place, where the solar wind meets Venus's exosphere, particles dance. They collide, exchange energy, and some get knocked loose off to join the long drifting tail. One spacecraft called it a comet-like structure. Another described it as a vast ion wake. But no matter the label, the image is the same: a planet trailing a ghost of its own atmosphere behind it. Elegant, haunting, strangely beautiful, and yet Venus remains unfazed. She doesn't resist, doesn't fight the solar wind. She simply allows it. She lets go of particles here and there like leaves falling from a tree. And she keeps spinning slowly, stubbornly, wrong way and all. Back on Earth, scientists watch these interactions with awe. Instruments trace the ion flows. Models attempt to replicate the loss. Satellites take measurements. But the tail keeps shifting, changing, reacting to the sun's moods. A solar flare. The tail lengthens. A quiet solar wind. The flow relaxes. Some theories even suggest that during solar maximum, those times of heightened solar activity, Venus may lose more atmosphere than usual, its tail growing longer and more turbulent. Others argue the effect is minimal, buffered by the thick clouds and lower atmospheric layers. There's no consensus, only more data to gather, more simulations to run, more tail to chase. And here's a quirky little angle. If we ever send a human mission to Venus, or even a high-altitude balloon crew, to float in the upper atmosphere, they'll have to account for this interaction with the solar wind. No magnetic field means more radiation. And while the clouds themselves can block some harmful rays, any spacecraft hovering above them will need solid shielding. You imagine that for a moment, a sleek vessel, silver-skinned, hanging just above the haze, solar panels extended, antennae twitching, instruments humming, and behind it, Venus spins, trailing her long, invisible signature across space. No banners, no sound, just the movement of ions, the slow loss of atmosphere, the gentle shedding of the past. You look down again. The clouds below are still golden, still thick, still impenetrable. But you know now that they're part of something bigger, something still unfolding. A slow story written in gas and particles and heat and history in tales that stretch across millions of miles. And Venus, she keeps going, still bright in our sky, still hidden in her heart, still beautiful and strange. Even as she leaves a part of herself behind, you drift in silence now, letting the tail of Venus stretch out behind you like a soft thread unraveling into space. The planet shrinks slightly in your view, but not your fascination. Because for all her mystery, Venus still holds more than just clouds and chemistry and suspiciously slow spins. It's time to look at her twin badge. Yes, twin. That's how Venus is often introduced in textbooks' Earth's sister planet. Our planetary twin, a fraternal match made in orbit. But the resemblance, as you've surely gathered by now, is only skin deep, and honestly, even the skin's a little misleading. Let's start with the basics. The mainstream fact: Venus is roughly the same size and mass as Earth, about 95% of Earth's diameter, roughly 82% of Earth's mass. Gravity on Venus is 90% what you'd feel at home. That's right, you could walk on Venus without bouncing around like a moon bunny. If, of course, you didn't immediately disintegrate from the heat and pressure. But gravitationally speaking, she's our equal. And from space, if you squint hard and ignore the lack of continents, she does look like Earth. Round, cloud-covered, reflective, mysterious. Venus is one of the brightest objects in our sky, outshone only by the moon, and sometimes Jupiter. Ancient cultures thought it was two different stars, one appearing in the morning, one in the evening. But it was always her, gliding along the ecliptic, outshining everything else with quiet confidence. So, what went wrong? Why did Earth become Earth with oceans and trees and Wi-Fi, while Venus became an inferno wrapped in acid? That's the million-dollar question. Or maybe billion-dollar if you're budgeting for a probe. Scientists still argue whether Venus ever had oceans. Some say yes, that billions of years ago, Venus was warm, but wet, maybe even temperate. Surface temperatures cool enough to allow liquid water, maybe shallow seas, maybe storms, maybe a chance at life. Others say no, that the sun was already too bright, that Venus closer to the sun never stood a chance at staying cool. Its water, if it ever existed, would have vaporized quickly, forming a thick steam atmosphere. And that steam? It's a greenhouse gas. It would have trapped heat, caused more evaporation, thickened the clouds, trapped more heat, and so on. A feedback loop. A runaway greenhouse effect. One bad summer that never ended. Either way, the result is the same. Venus's surface reached hundreds of degrees Celsius. The oceans boiled or never formed. The carbon dioxide that would have been locked away in rocks and seas on Earth stayed in the atmosphere on Venus. And with no plate tectonics to recycle that CO2, and no magnetic field to protect the air, Venus spiraled into its current state, hot, dense, and chemically grumpy. And that's what makes the twin idea so powerful and so eerie. Because if Venus had just a few different parameters, if it formed a bit farther out, Had a slightly different volcanic history spun just a little faster, it might have turned out like us. And if Earth had tilted another way, formed closer in, lost its magnetic field, failed to develop plate tectonics, we might be Venus. No blue oceans, no atmosphere you could breathe, no tick-tock. Here's a quirky detail to ponder. Venus actually receives about twice as much sunlight as Earth does. That's a lot. And with no moon to help stabilize its tilt or magnetic field to hold off solar radiation, the planet likely experienced chaotic climate changes early in its history. It's as if she had all the tools for success, and the solar system just said good luck and walked away. But you want to know what's really strange. Despite being so hellish now, Venus's cloud tops, the place about 50 kilometers above the surface, have temperatures and pressures similar to Earth's surface. It's not cold, not hot, just right. People sometimes call it the Goldilocks altitude. It's the only place in Venus's atmosphere where humans could theoretically survive without a pressure suit. You'd still need a breathing mask, and a heat shield, and acid-proof clothing, and a decent playlist for the balloon ride. But in theory, you could float there, live there. A cloud city drifting through Venus's skies. Somewhere between science fiction and real engineering proposals, there are sketches, balloons, blimps, solar-powered habitats riding the upper winds. NASA even has a name for a possible future mission, Havoc. High-altitude Venus operational concept. Sounds dramatic. Feels oddly hopeful. Floating above a world that once might have been Earth. And maybe that's the quiet pull of Venus. Not just that she's strange, but that she's familiar. You see your reflection in her atmosphere. You see your what-ifs swirling in her clouds. What if Earth had failed to form life? What if it had lost its oceans? What if it had spun the other way, the slow way, and ended up wrapped in acid alone? Venus is our twin in the way an echo is a twin. A mirrored possibility. A path not taken. Scientists still argue whether studying Venus could help us understand Earth's future. Climate models show that a runaway greenhouse is theoretically possible here under the wrong circumstances. It's not likely not with our current conditions, but the lesson is they're whispered in methane. And CO2 steer carefully, plan wisely. Planetary twins don't always age the same. You float higher still. Venus shrinks below you, now softening into a glowing coin edged in shadow. And even as you prepare to drift onward, you keep one eye on her, because she's not just a mystery, she's a memory. And a warning, Venus slips quietly behind you, now still glowing gently in your periphery, like the afterimage of a dream you're not quite ready to let go of. But we're not quite done. Not yet. There's one more thing she insists on sharing before the clouds close over her secrets again. Let's talk about time. Not your kind of time hours. Days, weekends that evaporate in the blink of a nap. No, we're talking Venus time. Here's your mainstream fact. A day on Venus is longer than a year. Yes, really. Venus takes about 225 Earth days to orbit the Sun. But it spins so slowly, 243 Earth days, to complete just one rotation on its axis. And remember, it's rotating backwards, which makes the math a little weirder. If you stood on the surface, assuming you could do that without melting, and tried to watch the sun rise and set, you'd be waiting about 117 Earth days between one sunrise and the next. It's not just the longest day in the solar system, it's practically passive-aggressive. And this brings up the question, no one can resist asking why. Why is Venus spinning so slowly? And why in the opposite direction of most other planets? Scientists still argue whether Venus was always this way, or if something traumatic happened early in its history. One major theory suggests that Venus was smacked by a massive object, a planet-sized hit, that slowed its spin and flipped its rotation, similar to the suspected collision that tilted Uranus onto its side. Another idea says gravitational interactions with the Sun and even Earth over billions of years caused Venus's rotation to slow down and reverse a process known as tidal deceleration. Basically, the Sun tugged on Venus's atmosphere for long enough to gradually twist it into a backward spin. But there's a quirkier twist. Some researchers believe Venus's thick atmosphere plays a big role in all of this. The air on Venus is so dense and full of movement, especially those speedy upper-level winds, that it creates torque. Over time, that atmosphere could actually influence how the solid part of the planet rotates. That's right. Venus might be spinning the way it is because its own atmosphere told it to. This has led to some truly strange models where air friction and solar tides perform an elaborate gravitational tug-of-war that affects not just Venus's speed, but its entire rotational behavior. You're looking at a planet where wind might steer the crust. It's like your shower steam deciding what time you wake up. And here's a cosmic cherry for your Sunday of confusion. Venus's rotation isn't stable. Over time, it changes, slowly. Sometimes it spins a little faster, sometimes a little slower. Spacecraft like Magellan and Venus Express have detected small differences, minutes here, hours there, between measurements, taken years apart. No one is entirely sure what's behind these changes, but one possibility is that the dense atmosphere interacting with the planet's surface creates drag altering the speed over time. Another suspect, Earth. Tiny gravitational tugs from our planet might actually affect Venus's spin ever so slightly, like a friend poking you in the ribs every decade or so just to mess with your rhythm. So, what does this mean for a day on Venus? Well, imagine you're living there again hypothetically. Let's say you set up your beach chair sunscreen, acid-resistant obviously, and decide to watch the sunrise. It takes over 100 Earth days to arrive. Then as the sun creeps overhead, it moves in the opposite direction of what you're used to. East doesn't mean what you think it means here. North and south, just suggestions. Venus doesn't care about your compass. Then comes the night, which lasts just as long. The temperature swings don't change much though, because the atmosphere is so thick, the planet retains heat incredibly well. It's like living in an oven that forgot to turn off. Whether it's day or night, you're still roasting gently under 92 times Earth's atmospheric pressure. But the real weirdness, Venus's bizarre timing, leads to an even stranger fact. A year on Venus is shorter than its day, but thanks to the direction of its spin and the motion of its orbit, the time between one sunrise and the next is less than its full rotation. This means, technically, if you stood in the same place, the sun would rise, set, and rise again faster than the planet actually completes a full spin. Welcome to planetary math. Bring snacks. You float above it all now, considering time in a way you haven't before. Not just clocks or rotations, but experience. On Venus, the world moves at its own pace, slowly, backwards, with no interest in your schedules or your expectations. Venus doesn't rush. She drifts. She turns on her own axis in her own time, and she doesn't ask for permission. Some planetary scientists love to say Venus is a cautionary tale, but maybe she's also a quiet lesson in patience. She shows up bright and early in our sky morning or evening, and then spins slowly, imperceptibly, under her yellow clouds. She's not here to impress. She's here to remind you that some things, like planets, like feelings, like questions, don't move quickly. They take time. They may even spin the wrong way, but they're still beautiful, still worthy of watching. You drift further now, letting the odd rhythm of Venus settle into your chest like a slow metronome. One long, drawn-out beat at a time. A day that stretches. A year that blinks. A spin that defies expectation. Out here, time gets fuzzy anyway, especially when the planet you're watching redefines it altogether. And as you turn your gaze toward the stars again, Venus keeps rotating, slowly, silently, as if she's got all the time in the universe and doesn't care what the rest of us think. Venus fades behind you now, her golden shroud retreating into the quiet black of space. But your thoughts stay with her, still spinning slowly, backwards, stubbornly, like a cosmic shrug in planetary form. She's made her point. Now let's talk about everyone else's reaction to it. Because here's the thing. When one planet doesn't play by the rules, it tends to cause a stir in the staff meeting of the solar system. Astronomers, modelers, planetary scientists, even the occasional astrophysicist with a coffee addiction, all of them keep coming back to the same question. How did Venus end up like this? Let's start with one mainstream angle. Scientists have spent decades building computer models of the solar system's early formation. These simulations show dust clumping into pebbles, pebbles into rocks, rocks into planetesimals, and eventually planets. These early planetary bodies then begin spinning, usually in the same direction they orbit the Sun, because of angular momentum. It's kind of like the cosmic version of everyone walking the same way around a buffet table. Orderly, predictable. But Venus, she grabs a fork, turns around, and walks the other way. One leading theory says that Venus once spun the normal way prograde, just like Earth, Mars, Jupiter, and most of the other planets. But something went wrong. Maybe a slow, off-center collision in the early days knocked her into a slow spin, or several smaller impacts nudged her over time until she ended up in her current retrograde wobble. That's right. Scientists still argue whether Venus was spun around suddenly by a major impact or gradually turned backward by lots of tiny gravitational shoves. Either way, what we're left with is a planet that takes longer to spin once than it does to orbit the Sun, and does it all backwards, like a celestial moonwalk. Here's a strange twist. In some simulations, a planet with Venus's current conditions can end up rotating slowly in reverse even without a big collision. If the Sun's gravitational tides pull hard enough on the dense atmosphere and the atmosphere fights back, you can end up with a kind of tug of war. One that Venus's atmosphere eventually wins, spinning the planet like a slow, atmospheric merry-go-round in reverse. So, yes, it's possible that Venus's atmosphere, thick, heavy, persistent, changed the direction her entire planet spins. That's like your bathwater getting so steamy it starts turning your bathroom door. Weird. Yes, but kind of beautiful in a science fiction meets climate physics way. Now let's go a little more fringe. Some researchers have speculated that Venus and Earth might have once been in a kind of orbital resonance. That is, they tugged on each other subtly, but repeatedly shaping each other's paths and rotations over long periods. Think of it like two people swinging on swings, just slightly out of sync, giving each other little pushes now and then. If this happened, it's possible that Earth's gravitational nudge helped slow Venus down over time, or even contributed to her reversal. You could say we might be partially responsible for her weird spin, Sorry about that. Others have proposed that Venus's rotation is in some kind of temporary balance, that she might start spinning faster again in the distant future, or even flip back the other way. It's not likely, but planetary physics is full of these long-term wobbles. Time is slow out here, really slow. Venus could be in the middle of a billion-year pirouette, and we just happen to catch her mid-reverse. And here's a delicious little tidbit. Venus's retrograde spin makes her the only planet in the solar system where the sun rises in the west and sets in the east. It's not something you could easily witness from the surface given the clouds and the temperatures and the being crushed like a soda can situation, but it's true. Sunrise on Venus is a backwards affair. Even the idea of day and night gets fuzzy here. Between the slow spin, the thick clouds, and the way sunlight filters through the dense haze, there's no clear delineation between light and dark. The entire planet glows softly. You'd need instruments just to know what direction the sun is, let alone where it's rising. Imagine twilight. Forever. But also, it's 860 degrees and raining acid. So you know, mixed vibes. The more you think about it, the more Venus starts to feel like the solar system's artistic sibling. She doesn't care about your expectations. She doesn't need to match the drapes to the couch. She just spins the wrong way. Slowly. Proudly. And she makes it look good. And this backward spin has one more trick up its sleeve. It complicates everything we try to do when we send spacecraft there. For starters, Venus's slow rotation means no helpful boost from planetary spin when launching or landing. On Earth, we take advantage of our eastward spin to fling spacecraft into orbit. Venus doesn't play that game. Its slow retrograde turn actually works against orbital mechanics in certain scenarios. And let's not forget that thick atmosphere. Any lander we send in has to endure not just extreme heat and pressure, but winds that shear in multiple directions, layers upon layers of turbulence, and a surface that turns oh so slowly underneath. Imagine trying to parachute onto a carousel that's not only spinning backwards, but also coated in fog and set on fire. Still, we keep trying. Because Venus, despite all her stubbornness, remains one of the most compelling mysteries in the solar system. Her clouds hold clues to atmospheric dynamics we don't yet understand. Her spin tells us stories about early planetary evolution. And her similarity to Earth, the near match in size-mass gravity, makes every difference between us that much more important. She's like the alternate ending to our story. And as you drift above her, now thoughts swirling with solar tides and atmospheric torque, you start to appreciate what that means. It means you don't need to follow the rules to be part of the system. It means backwards isn't wrong, it's just different. It means that sometimes what looks like chaos is just a different kind of balance. Venus spins slowly, backwards, alone. But she's not broken. She's just choosing a different rhythm. You float now in a kind of stillness adrift above Venus, its honey-colored clouds stretching out below, like a soft quilt that's hiding a furnace. The planet turns beneath you slowly, silently, defiantly. And while we've talked a lot about spin direction and heat, there's another mystery worth pausing over before we begin to drift away: Venus's mood swings. Let's talk about atmosphere. Again. But this time, not just what it's made of, but how it behaves over time. Because Venus, for all its slowness, can sometimes change fast, and not just at the surface. Here's your mainstream fact. Venus's upper atmosphere rotates about 60 times faster than the planet itself. This phenomenon is called superrotation, and it's exactly what it sounds like. Winds so fast they whip around the planet in just 4 Earth days, despite the surface taking 243 days to complete one slow backward spin. It's like the air got bored waiting for the crust and decided to run laps on its own. Now here's the thing, this isn't some small breeze. These winds reach speeds over 300 kilometers per hour, racing across the cloud tops like a jet stream on a caffeine bender. And somehow, they manage to do this consistently. Every probe that's ever peeked at Venus's upper atmosphere from Pioneer to Akatsuki has confirmed the same thing: wild, persistent wind speeds that boggle the modeling community. But scientists still argue whether we actually understand how this works. There's no single accepted explanation. It could be due to solar heating, or the planet's rotation, or a bizarre combination of convection tides and chemical feedback. One suggestion is that the dense atmosphere generates waves, kind of like sound waves, that move heat and momentum around in strange ways, helping to accelerate the air. But no model gets it exactly right, and that's not the only head-scratcher. Venus's atmosphere doesn't just spin, it breathes, in a weird slow-motion kind of way. Over the years, scientists have noticed that certain features in the atmosphere seem to pulse. Pressure levels change, cloud structures fade and return, sulfur dioxide concentrations fluctuate dramatically. In fact, here's a wonderfully quirky fact. The amount of sulfur dioxide, the stuff that contributes to Venus's thick clouds of sulfuric acid, can swing wildly in just a few years. One moment you've got layers of choking haze, the next it's mysteriously thinner. Scientists suspect some form of volcanic activity could be responsible, possibly even modern eruptions. Yes, real-time eruptions hiding beneath the clouds, releasing gases into the sky. So yes, Venus might be volcanically active right now. We're not talking Mount Doom or lava rivers you can spot from orbit, more like subtle pressure events. Puffs of gas, maybe even slow-creeping lava flows under 90 atmospheres of pressure. You wouldn't see much from space. But Venus's mood, you'd feel it. And then there's the mysterious UV absorber. Sounds like something you'd buy in a skincare aisle, but it's actually a thing that scientists discovered while observing Venus in ultraviolet light. Certain bands of UV get absorbed strongly in the upper atmosphere, but no one knows what's doing the absorbing. Some sort of particle A molecule aliens with SPF 10,000 umbrellas. Kidding, probably. But the point is, we don't know. Venus hides her secrets in layers. She gives us strange data, erratic wind speeds, mysterious chemical dips, and asks us to figure it out while she spins slowly backwards and unbothered. Let's zoom in a bit more now. Imagine yourself drifting with the upper clouds. Everything around you is thick and golden, like swimming through sunlight. You can't see the surface, no one cannot, with human eyes. Even radar maps need to be carefully teased from bouncing waves and refracted pulses. But if you could peek through, you might spot plains covered in volcanic rock, massive shield volcanoes that dwarf anything on Earth, lava-scarred basins with names like Mont Mons and Sapos Mons, places that suggest heat still simmers under all that pressure. And scientists still argue whether the whole planet might be in a kind of stalled geological state. Like it's between tectonic chapters. Earth has plate tectonic shifting crusts, subduction zones, the whole continental shuffle. Venus? Not so much. Its crust appears to be one large, mostly unbroken shell. That means no plate movement, no continents drifting across oceans. Just heat trapped inside with nowhere easy to go. So, when it does escape, it might do so in bursts, big, planet-wide episodes of volcanism. Some researchers believe Venus goes through cyclic resurfacing events, huge periods where much of the crust melts, reforms, and resets. If true, that would explain why Venus's surface looks geologically young. It's been through a few planetary glow-ups, and then it chills. For a few 100 million years, like a volcano that took a sabbatical. So now, you're drifting over this weird, stormy, glittering cauldron of a planet and realizing that it's not just spinning backwards or cooking under clouds. It's unstable, quietly, slowly, beautifully. A place where things shift under the radar literally, and no two visits yield the same measurements. That's part of the allure, really. You don't come to Venus for consistency. You come for the mood swings, the quiet contradictions, the sense that something's happening, even when it looks perfectly still. And maybe that's why we keep planning missions. There's Veritas, a proposed orbiter that'll use radar to map the surface in greater detail than ever before. There's Da Vinci Plus, another mission concept that plans to drop a probe through the atmosphere to directly sample the gases and learn how it all came to be. These aren't just fancy acronyms, they're dreams. Hopes that we can peel back another layer of Venus's disguise and finally get a clearer picture of what makes her tick. But she's in no rush to explain. As you drift higher, letting the atmosphere thin around you, Venus's cloudy tops begin to blur again. The winds continue their fast dance above the slow turning surface. The sulfur dioxide pulses somewhere out of sight. And deep below, something might be bubbling, just waiting for its next breath. You're almost above it now. The last wisps of Venus's atmosphere spiral beneath you like threads of golden silk. The planet is shrinking again, slowly, gently falling back into the black as you rise. Not in a rush, not chasing answers, just drifting upward like a balloon left to the wind. Venus spins behind you, still backwards, still slow, still doing her thing without apology. You've spent the whole night with her, haven't you? Wandering her clouds, peeking through the haze, trying to catch a glimpse of what makes her so delightfully difficult. And now as she fades, you realize something she never asked to be understood. She's not here to explain herself. She's here to exist. And oh, does she exist with flair? Let's close with one last puzzle. Because this is Venus, and she wouldn't let you leave without at least one more mystery to carry home like a souvenir. Her magnetic field, or more precisely, her lack of one. Here's your mainstream fact. Venus doesn't have a global magnetic field. Unlike Earth, which has a powerful protective magnetosphere generated by its spinning molten core, Venus seems to lack such a field entirely. And scientists still argue whether this is due to her core not spinning fast enough, being too cool, or just not convecting the right way. The absence of a magnetosphere means Venus is far more exposed to solar wind than Earth is. Particles from the sun slam into her upper atmosphere, stripping away some of the lighter elements. Over billions of years, this may have helped Venus lose most of its water, what little it had, and left the atmosphere heavy dry and acid thick. But here's the quirky twist. Venus does have a kind of magnetic ghost field, called an induced magnetosphere. Solar winds hitting the planet's ionosphere can create a temporary fluctuating magnetic bubble. Not stable, not strong, but real. It's like the planet whispering back at the solar wind, "I'm still here," and somehow that fits. Venus doesn't make grand statements. She doesn't shine with auroras. She doesn't ring with radiation belts like Jupiter. She just hums quietly in the background, glowing softly, breathing in clouds, turning the wrong way and not caring a bit. You think about how many times Earth has been compared to Venus, similar in size, similar in gravity, roughly the same age, but utterly, utterly different. It's like they were twins, raised in separate galaxies, one green and blue, full of oceans and laughter, the other hot, dry, and wrapped in velvet storm. And yet, you can't help but wonder, did Venus choose this? Of course not. Planets don't choose. But if they did, you'd believe it. You'd believe Venus looked at the chaos of the early solar system and said, you know what? I'll take the long route, the slow turn, the heavy clouds, and no thank you, I don't need a magnetic field today. Because what she became is hauntingly perfect. Not hospitable, not gentle, but unique. A world that's both familiar and completely alien. A place that reminds you of Earth, only to whisper, not quite. You've traveled through her skies now. You've heard the winds that race without sound, seen the clouds that never clear, and followed the spin that runs against time itself. You've peered into her heat, her haze, her hush. You've lingered at the edge of a planet that should make no sense, and yet does in the most Venusian way possible. And as you drift back, farther past the clouds, past the glare, past the edge of understanding, there's nothing left to solve. Not tonight. You can't fix Venus. You can't translate her backwards poetry. You can only listen, watch, float. So let's do that. Let's take one more moment with her. Let the planet shrink into the distance like a glowing ember you're reluctant to leave. Let the storms keep swirling behind the curtain. Let the clouds glitter maybe, or maybe not. Let her spin in silence, undisturbed and undisturbable. There are more missions to come, more questions to ask, more data to gather, but not now. Tonight isn't about decoding. Tonight is about drifting. So settle in, close your eyes, and let Venus keep turning slowly backwards exactly the way she likes. Now take a deep breath, let it out slowly, like the soft wind you never heard on Venus. The kind of wind that isn't made of air, but of time. You're far from the surface now. Far from the clouds, the acid haze, the burning rocks, and the reverse sunrise. You're wrapped in distance, in silence, in the deep stillness of space. The planet grows smaller behind you with each passing thought. She's content to be unreadable. And you're content to stop reading. Let your mind drift the way the clouds did across the sky, around the curve, slow and unbothered. Let the light from the sun reach you not as brightness, but as warmth. Soft, diffuse. A comfort you carry, not something you chase. There are no alerts out here, no questions demanding answers, no mysteries tapping you on the shoulder. Only you, the hush of space and the graceful patience of a planet that never once asked for your attention and yet held it so gently all the same. You can come back to Earth anytime, but not just yet. Linger in the dark a little longer. Float above the quiet planet with her soft storms and even softer answers. Let your heartbeat sync with the slow spin of Venus, a rhythm that doesn't rush. And in this stillness, remember, some things are beautiful, not because they make sense, but because they don't. You're safe. You're adrift. You're stardust again. Good night, traveler.